We've got a very fun session coming up. So we're looking forward to some Kubernetes security and some interactive hacking the playground, right? So Kubernetes is obviously one of the largest, or if not the largest, open source project in the cloud native ecosystem. Definitely has its nuances. There's a reason that everybody loves the security talks about this tool because it's simply just massive. We had a couple of good sessions yesterday related to it, and Madhu, I'm really looking forward to seeing the Kubernetes Goat playground that you all built and taking a tour through it. So with that, go ahead and get started, and we'll catch you on the other side here. Have a great session.
Thank you so much, Eric, for the introduction. Yeah, so today I think I will just share the screen. Could you please confirm if it is all working fine?
Yeah, we can see the agenda for the summit.
Yeah, perfect. So as you see, I think today's talk will be a bit different context. As of you've seen quite different talks. This is completely trying to be like a real world and hands-on in a live mode. So today I'll be using no slides and trying to showcase the live demo of the entire Kubernetes code. So as you see, the talk is about Kubernetes Goat, which is an open source project to teach and learn about Kubernetes security in an interactive way. So little bit about me, myself, Madhu Akula. I have been working at Miro as a security engineering. And apart from that, I have been doing quite a lot of research and things around cloud containers and Kubernetes security for quite some time, and trying to present my research at a bunch of the conferences and things around. Right? If you wanted to follow me, you can use any one of the social media, and happy to connect. So coming back to the session, today we will be looking at an open source project called Kubernetes Goat, which I have created out of the need where I wanted to learn and understand how I can learn about Kubernetes security issues and how I can fix them so that I can able to provide my security value for Kubernetes clusters when performing pen testing or performing architecture reviews or security assessments, right? So by the way, this is completely open source, which means you can go ahead and try out yourself. There is an online guide as well. Like all the documentation is available here, which is step by step. And we will be leveraging this documentation throughout this session and see some of the hacking scenarios as well as defense scenarios, right? So as you see, I have also opened an online playground, which is already set for the Kubernetes cluster. And also have my local cluster, which is already up and running with Kubernetes, right? So without further ado, let me start the demo and the session. So a bit about the project. As you know, it's an intentionally vulnerable application. So I would highly recommend, please do not run this cluster alongside your production workloads or any sensitive infrastructure, right? So try to create a test environment, or in a bit, I will showcase how you can leverage this online playground as well. And as you see, yesterday itself for the just SANS talk, I have uploaded 5 more extra scenarios focusing on defense. So this has quite a lot of security scenarios and how we can learn about Kubernetes security and attacks. So let me go ahead and showcase a bit more context. So if you are someone coming from a security background and wanted to learn about Kubernetes security, I would highly recommend go ahead and learn about Kubernetes technology itself. It's quite important to understand the technology to provide your security value or to understand security issues or misconfigurations. So I would highly recommend you get started with this very fun way to learn about Kubernetes using children's illustrated guide. And also they have a pretty heavy documentation in Kubernetes documentation itself. And also they have quite a lot of tutorials, which are quite hands-on, and to get started, how you can deploy a simple application to the Kubernetes, right? And so if you look at like the high level architecture before diving into the security parts, right? So Kubernetes is consists of 2 different parts. Like if you look at like master and node, which means that it acts like the control plane, the master, where you have a bunch of components like API server, control manager, scheduler, and all. And in the node side, we have container runtime, which has pods scheduled and other services like kubelet and kubeproxy, right? So whatever one of the key functionality we will be looking here is the API server. this is like a brain for the Kubernetes. Like whenever, if suppose external developer wanted to talk to the Kubernetes, or like internal services or the applications and servers, will go ahead and talk to the Kubernetes API server, which has like a API server interaction with the other services like control manager. If suppose, do we have this desired state applied, or this application running with these many number of pods, like that, right? And scheduler is the job where it will ensure that, okay, we have now, this is the application wanted to deploy with n number of replicas, and it will ensure, do we have those resources in our nodes? Do we have those memory and CPU consumption, right? So it's like completely distributed systems, right? So I would highly recommend a bit more deep dive into Kubernetes before learning about the security for sure, right? So as I said, if you are someone like already just get started with Kubernetes and now trying to get into security, then I would recommend start with this playground, which is nothing but a online setup. So you don't need to do any local Kubernetes cluster setup, which is you can just launch the cluster and set up the Kubernetes code, right? And if you are someone who already has the cluster locally, you can also follow these instructions and clone the repository and set it up yourself as well, right? Which I have already done. If you see in this case, I have cloned the Kubernetes Goat and set it up, right? So let me start showcasing the scenarios. You can get started with setting up the bash setup Kubernetes code, which is nothing but a setup script, which has a bunch of Helm charts and multiple Kubernetes manifests, which are intentionally vulnerable scenarios, which is going into deploy into the Kubernetes, right? So if you look at kubectl get pods, you can, you can see the bunch of pods which are running as part of the deployment, right? So that's good. So now we have all the setup is running. For the sake of the learning, we kind of try to design in a way flag system like CTF way, but not all of the scenarios has this structure. But if you find any KTS code with a flag this format, like then that means like you kind of reach the scenario end, like because there are so many other ways you can exploit as well, right? So we kind of define this as a like a end goal, something like that. Cool. As you see, there are quite almost 20 scenarios nearly. So before diving to that, I think I wanted to just give a context, right? So there is a really good research done by the community, by CNCF, and published white papers. And especially we are trying to leverage and explore these threat modeling, right? Like we are trying to exploit these boundaries and between the API server and the pods and in between the communication and how the user interacts, right? And similarly, we are trying to map some of these scenarios with attack trees, like where, which means that, okay, we wanted to achieve and gain access to sensitive information. It doesn't matter which path you follow. I think definitely you can't see this image, but it doesn't matter which path you follow. The end goal you wanted to reach is gaining sensitive information, right? So we will see some of these scenarios. And also we try to see how we can map these to Mitre framework. Like this is like a Mitre framework for Docker containers, and this is for the Kubernetes. And there are a bunch of scenarios which covers some of these parts like lateral movement and credential access and privilege escalation parts, right? Cool. So with that, let me start accessing the Kubernetes Goat locally by running a access Kubernetes Goat, which basically expose all these services into a local system using port forward, which means that you can only access, not in the internet, everyone who has access to this IP address or service, right? So once you started, you kind of get this interface. This is like a Kubernetes Goat home, which kind of help you to, this is the guide which we are following currently to go through these scenarios, right? So there are quite a lot of scenarios, as you see. I don't think so we were able to cover within this short amount of time, but I'll try to focus on some of them. But it's definitely, you can go back and try out all these scenarios to learn about different security issues and misconfigurations, right? To get started with, let's look at one of the common scenarios. I think you might have seen this quite often, right? Like this doesn't mean to be just Kubernetes. In general, most of the modern infrastructure and cloud native systems where developers tend to mistakenly commit these sensitive keys, maybe AWS access keys, secret keys, or API keys. So in this scenario, we will try to look at one of the example, like where there is a simple service running, which is build code, where it has like mistakenly committed secrets into the container, right? So as an attacker, once you see the application, you go ahead and enumerate the application and browse, perform reconnaissance, right? So as similarly, you can see in this scenario, we have seen that there is a Git folder with config available, right? Maybe you will just don't get directly to this part, by the way, when you are testing. Maybe you will try to do some reconnaissance, like do we have robots.txt, and do we have like any files, or run some kind of tools like Dirbuster and something. But once you understood that and identified there is a Git config, now you, as an attacker, you can clearly see that there is a Git running, and which is a bare repository remote site, right? So you can leverage now this guide, also follow the solution if you want. There is a way you can solve these challenges by using different methods. So in this case, what we are trying to do is we wanted to leverage this and clone this remote repository locally using a Git dumper, which means that I can go ahead and clone this remote repository and into the local system, right? Sorry, I think I already installed Git dumper. Let me just remove this. So you can see that now we are cloning the entire remote repository into a local system with the vulnerability is because of misconfigured Git repository is committed to the remote system, right? So now you can go and explore this Git repository which we cloned. Like we can see that there is a bunch of code which is lying there. You can definitely get the entire source code access. And also you can see, interestingly, there is a bunch of Git logs also, right? So as an attacker, you can understand that people tend to mistakenly commit some of the sensitive information and forget, right? Similarly, we created something where if you go to one of these commits in older version, so you can see that there is a one env file which is lying, which has a AWS access key and secret key, right? So which means that basically if an attacker has compromised misconfiguration credential and they were able to obtain, they not only get exploit and gain access to your applications, they can even go beyond and access your cloud resources, and from there based on the how you commit it, right? So this is a very simple scenario, an example how you can leverage and learn about Kubernetes security using Goat. And there is a different ways also, like how we can use these kind of tools in CI/CD systems like Trufflehog, and identify these in the early stages of the container scanning itself, right? So that's a quick example. And I think maybe let me cover two more scenarios if possible. So another thing which we commonly see is in Docker socket, which is Ding. If you are someone leveraging the pipelines and CI/CD systems, most of you might be building your Docker containers in the build systems, right? To build these Docker containers in the build system, you might need to have a Docker socket exposed, which means that they will use the Docker socket to build the system, right? By leveraging the underlying. So this is a simple application which has an intentionally vulnerable called remote code execution. And you can just see that when you do like the ping and semicolon with separated to ID, which is like we are trying to give the command to the remote server where the container is running. And we can see there is a response from the container with the UID root and every data, right? So from here, this is like a basic application security vulnerability. As a Kubernetes security, or like how you want it to perform, is you can think about how you can explore a bunch of options. Like, do we have any mounted directories from the Kubernetes system, right? If you see here, there is a Docker custom socket mounted into this container, which means that you are able to access to the Docker socket, which is underlying in the host system, which means that you are one more level on top of the host system, right? So I'm just trying to use this documentation again. So what I'm trying to do is, as an attacker, I can go ahead and download the static compiled Docker binary and able to interact with this Docker socket, right? So what I'll do is I'll go ahead and download this Docker binary into the temp directory in the local system. So once I download it, I will go ahead and extract this binary into the local system. Then I can able to interact with this Docker socket by passing the -h flag and the socket path, which is the Unix socket, right? Then you can literally interact with the host system, which means you can able to run any Docker container, and you can create a backdoor and connect the reverse shell back to your host system or attacker machines. And you can imagine how much damage you can do as the pen tester or attacker, right? From here. Looks like it's going to download this. It's taking a bit more time. Let's just wait for some more seconds. So sometimes it looks like downloaded, and I'm going to extract this package. And once I extract, I will go ahead and see if I can able to interact. I think this is just waiting or stuck. Let me just refresh. And just to confirm, let me just see if the files are there in the Docker path, right? Yeah, it looks like it's there available. So now I can use the Docker, which is extracted, and the binary, and I'm passing the Docker socket, which is in the custom path, and I'm running a PS, which means to showcase what are the running containers in the host system, right? So what it does is it will go ahead and run this command. Oh, looks like it's broken. Yeah, I think it is just a bit a glitch. Let me just see if I can leverage this here. Meanwhile, I'll just trying to showcase another scenario. Maybe I'll just go ahead and download again, maybe. Uh, so So I will just trying to access the same thing here, and I will go ahead and download this binary in another service. Cool. Meanwhile, I'll try to showcase the different scenario as well. Like similarly, you can see there are a bunch of other scenarios where people can leverage because of there is extra privileges and how they can gain access to the underlying host system by escaping out of the containers and to the host systems, right? Like if you see this example, like we have think of it as we got access to one of the container in our pod in the Kubernetes cluster, right? So from there, as attacker, what else you can do? So you can also explore the file system. So if you see here, there is an extra thing which is mounted called host system. When developers or some services which require extra capabilities or extra volume mounts, we can leverage these kind of capabilities to attack and exploit the container privileges, right? So in this case, what we are trying to do is this container has privileged access and also mounted the host system, right? So what we are trying to do is we are doing chroot on top of the mounted file system, and we are executing the bash, which means that whatever the commands which you run, you're going to run inside the host system. Like if you do Docker PS, it is going to run inside your underlying hosting system on top of the Docker container. So you can literally see we can get access to all the containers in the host system. And from here, you can literally exploit and execute like an attacker. So you can also go ahead and look for the Kubernetes configuration, which is, I think you have to go in the pathway, like a host system, var lib kubelet, and you can see all the data which is regarding the kubelet resources. And also you can look at etc Kubernetes and kubelet config, so which will provide the Kubernetes configuration and the token to access to the Kubernetes API server. And from here, you can use this, even this token or like the node level, the policy or the certificates to talk to the Kubernetes API server to further exploit, right? So a simple example could be like, maybe I can use kubectl, the same command line, to talk to the using kubeconfig and get the pods. Because whatever the permissions this kubelet has, we can able to use those permissions and able to run those commands inside this nodes as well. Now you can see that we can able to even get the pods from the node system, because whatever the kubelet permissions which has is allows to perform the get pods operation, right? So we can quickly check by running like kubelet kubeconfig, and I'm trying to check if I'm authorized to get the pods using this configuration. You can see that it is saying yes. And similarly, you can understand what kind of permissions or privileges this token which you can do by checking, like I'm trying to check if I can able to delete the nodes with the same access which I have. You can see this, the token which is I have and able to talk to the API server doesn't have the capability to perform delete node operation, right? As an attacker, it's like from here, you can do further more exploitation. You can go ahead and deploy another pod and go ahead and deploy in another node and gain access to another node, which means you can literally have access to all the Docker containers. You can go and even explore and extract the data sensitive information and gain access to the source code and much more configuration, right? So you can use hop and hop and gain access to the complete cluster in this way as well, right? Yeah, that is the one of the example of container escape scenarios. And similarly, there are a bunch of other use cases if you wanted to try and leverage and how you can run Kubernetes CAS benchmarks. Maybe you can also go ahead and try this as well. It will try to showcase and give you what all Kubernetes security issues in a Docker way. And also there is a Kubernetes CAS benchmarks, which will provide Kubernetes security issues also. So you can go ahead and run this deployment, which will deploy the CAS benchmarks. Then you can able to access that CAS benchmark container and go ahead and run the Kubernetes benchmark security or Docker bench security. Right? So let's look for the pods which is created, and you can see this it's running. I can exec into the pod which Docker bench security got just created. So now you can see that Docker bench security is there. Then I will just go ahead and execute the Docker bench security. Then it will go ahead and perform all the security benchmark checks on top of your Kubernetes cluster in the specific node, and provide all the security results and provides how much security posture it has as per the CAS benchmark standards, right? And I think with that, I don't want to cover much more scenarios and bore you with this. And also, this is a very interesting scenario where if you, I even see when I was doing pen testing engagements, even modern clusters, due to the legacy deployments, we still see some of the versions of older version of Helm Tiller running. With this, you can not only get access to one of the node or pod, you can literally access and gain complete cluster compromise of the entire Kubernetes itself, right? So this will give you like the complete cluster admin privileges by leveraging the tiller, which is the server-side component of the Helm chart, right? And there is also a really good interesting scenarios where you can go ahead and explore about namespace bypasses. This is quite interesting because as an attacker, you think that Kubernetes gives different namespaces. Those are completely logical boundaries. By default, Kubernetes is a flat networking scheme, which means that any pod or service can talk to any other pod and service, right? So if you look at this example, I will go ahead and run a simple hacker container. By the way, this is designed to perform and test Kubernetes security assessment, which has a bunch of tools built in. So if you see this, we are running this container in a default namespace. What I'm trying to do as attacker is, okay, I'm trying to understand what kind of IP address I have and what kind of cluster range it has, so that I can scan for this entire cluster range to see any other services available. It's like simple traditional network security scan like with Nmap, but in the entire cluster range. So what I'm trying to do here is I'm trying to use Zmap rather than Nmap to make it much more faster. So, and rather than looking for all the sources, I'm trying to look for only specific port because I just know for this demonstration purpose, there is a Redis running in the sys cluster, but in general, you wanted to run this on all top of the all ports, right? So for this, I think looks like I have to whitelist this IP address in the specific configuration of Gmap. Let me quickly do that. Yeah. So, and I think I also have to provide the hardware address for the Zmap with the flag, I think. Yeah, -h. And provide this hardware address. Gateway. Yeah. So now it will go ahead and perform the entire cluster scan for the 6379 port and see if any service running with the 6379 port and put it in the results.csv file. So it will take a bit the time to scan the cluster. And once you see this, now you can able to get not only one namespace, because Kubernetes can have multiple namespace. We can even gain access to other namespace services, which doesn't have network security policies applied, and able to like just deploy the applications or microservices, right? So I think it will take a bit more time. Let me leave that scenario and come back after some time. But similar to same way, we can also see some of the defense scenarios as well, like how we can able to perform audits on top of Kubernetes using kube audit and get all the information or resources, and also looking for security runtime monitoring using Falco, which is open source tool by again CNCF community, and which provides what kind of attacks or things happening in the Kubernetes cluster, right? So to just showcase a simple demonstration, how we can detect certain kind of file integrity checks, for example, in the containers, right? So if you see this example, so we are already running a Falco and we can able to see those logs as well in the real time, right? So what I'll do is I'll go ahead and spin up another container with a hacker container with a simple bash shell. Let me just keep here so that you can see the both terminals. So whenever you see the terminal getting triggered, the started, and you can see that there is a execution of Kubernetes happen. So you can see those logs coming in the sysdig Falco as well, right? Similarly, I think there is quite a lot of traffic that you can see. So let me just do a simple command. Like if you read any sensitive files like cat etc shadow or something, you can even see that it gets triggered in our Falco. Like whenever you read that, so you can see that this kind of detected by our Falco that, okay, we have opened some specific file for reading or writing some sensitive file, and it provides which container it is performing, and what is the container ID, and what kind of command they ran in the container. Also, it gives all the detailed information from the runtime perspective, right? So I would highly recommend you can try these all scenarios, and once you are done, you can go ahead and also tear down the cluster if you are setting up locally. And if you are using a remote setup, you can go ahead and stop this session, and it will automatically destroy this cluster and resources. And also, if you are someone like wanted to look for different kind of security results on top of this, we also did a assessment using different open source tools like Kix and Checo, like what kind of security issues it found on top of Kubernetes, and how you can integrate this so that you can perform in CI/CD scanning for understanding the security risks at the early stage itself, right? Like identifying there is a privilege escalation allowed, all these kind of security issues. With that, I think that's kind of what I have with the talk. And definitely, I would highly recommend give it a try. And there is an extensive documentation available in this place. And you can also raise any issues if you wanted to see a new scenario. And please feel free to contribute as well. I hope it will help you in learning more about Kubernetes security and understand better.
Excellent. Thank you, Madhu. That was awesome. I'm always amazed, especially as quick as you were typing and zipping through that. It was just truly impressive just doing the live walkthrough. I think very entertaining to watch. I think the thing that impressed me the most is the documentation that you've got there, just walking through that wiki and all the different learning scenarios and, you know, just the different ways that you can kind of break into one of those clusters. Yes, somebody did ask if you could post the link, you know, to the wiki. So maybe if you want to bounce into your hallway channel and drop some of those links in there, I think that would be definitely useful for some folks to play with. My main question for you. Okay, so we just watched you running basically a self-managed or hosted, you know, cluster on your machine, and you identified all those moving parts. Now, knowing that ecosystem inside and out, if you're faced with a choice, whether we're going to run this thing in production, are you doing this on your own on a cloud VM like GCE or EC2, or are you going with GKE or EKS in a cloud managed Kubernetes cluster to reduce some responsibility model? What are your thoughts on that?
Yeah, I think that's a definitely good question. In terms of the security perspective, I think definitely when you choose the managed services, it's always shared responsibility. The cloud provider will take care of so many security issues, and you as a customer or the responsible developer, you will take care of some of the security issues. I think it will reduce, especially like a GKE or EKS Fargate. Like they don't even provide the access to underlying daemon set, which means no one can go ahead and bypass and get access to the node level. And also they don't provide some security mistakes also. EKS Fargate still doesn't support NSPs, which means network security policies are not there. So these might not be useful some critical infrastructure like banking, but it's a good start if someone wanted to get. And definitely managed services taken care of so much security burden from you, but still there are some security misconfigurations. If you don't play properly, it will definitely lead to big compromises in the cluster.
Yeah, that, it's kind of the debate. I always ask that because it's fun to be in full control of things. And like you said, if you go through each and every one of those steps to harden it appropriately, you may be better off, than the managed service. But how many folks or, system administrators are going to go through that and scan it with all those tools and make sure that we've enabled all the right configuration settings and things like that? Really cool project. I think we've got all of the questions, at least that I have seen, answered. Lots of kudos going on in the hallway channel for you. So feel free to drop in there and chat with folks. I think everybody's loving the demo and that project in general. Really, really cool learning tool. So thank you on behalf of all of us for helping build and maintain that open source project. Really awesome. And thanks for sharing it with us.
Thank you so much. And it was my privilege to share the project and the talk. Thank you so much.